Hi, good evening. Thanks for joining.
Good evening, sir. Good evening, sir.
Yeah, good evening. Good evening. So, how it's going? Can you able to catch up or you're doing the assignments?
Sorry, since it has been pending, sir. Since it has been pending.
Okay, okay, okay.
Once after complete three sections, then I'm to enroll, sir.
Okay, okay, okay. So, you can able to follow up, right? Any difficulties or
Sir, according to my knowledge background, I thought a field conversion of the units there and faced challenges, sir.
oh, okay, 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 okay. So, we are from civil department or what?
Yeah, within department, I'm to choosing this course, sir.
No, are you from civil department?
I'm from civil departments.
Okay, okay. Which year?
Currently I'm studying final year, sir. Core
Okay,
one.
okay. So maximum unit conversion will be from milligram. Actually, for discharge, for volume, for flow, that is the speed, and for time. These four are very important physical parameters. If you see, so Q will be the discharge meter cube per second. Always you can remember. Volume will be meter cube. Time will be second, and speed will be meter per second. This four, if you remember, just replace the formula. And sometimes they will give in million liters per day, so just convert the m into 10 power 6 liter per day, so L by D. Then liter to meter, 1000 liter is 1 meter cube, so that conversion you need to know. So this is basic. If you know this alone, you can able to do lot of sums. I think
Thanks.
yeah,
Thanks for sir, your clarity to show out shortly my face currently.
sorry.
Thanks for your given
Yeah,
time
yeah,
to
yeah.
me.
If you want,
Only
I
shout
can
out
try
whatever
to.
you
If
feel.
any formula conversion file is there, I will try to send you. Maybe I will upload in the reading documents. You can follow up tonight. I will send you. Yeah.
Okay, so sir, in the week of the fourth, there itself a lot of problems that would be confusion while you checking.
Okay. Anyway, I am having one more additional session after 12th week. Maybe same on Monday, I guess. So there you can ask whatever the questions you have. You can come. And I am also going to discuss the 12-week assignments what we did in the 2025 session. That also I will discuss again with the solutions. So if you have any more questions, I will answer there. It may be 2 hours or more than also I can sit and answer in that session.
Thanks for your support, sir.
Yeah, yeah. 13th week you can. I think you will get the mail for the extra session. That there you can join. I'll help. No issue. Okay.
So this course is being part of my semester itself. That's why I'm to be focused.
Yeah, yeah, yeah. Whatever doubt you please ping me. If you can't clarify in the meeting also, you can personally contact me. No issue. Anytime. Which institute you are from? You are in the final year, right? You are studying wastewater treatment in the final year.
Yeah, sir, it is in final year, wastewater treatment.
Oh, you have environmental one, environmental engineering two, and all right. Water treatment, wastewater treatment already.
Yeah, already that has been completed in environmental science,
This
environmental
is
engineering.
yeah, yeah. But this is as a elective you are taking.
It's nothing to elective. So instead of four subject, that I'm to be
Okay, okay,
chosen.
okay, okay.
Actually, in the place of pre-cost pre-concrete costing
Precast
is there,
concrete.
right?
Yeah. Okay.
In place of that, I'm choosing this course.
Okay. Nice. Water treatment will be easier, easy to understand, but if you know the concept, you can easily crack it, no issue. So whenever you have doubt, you can ping me, no issue. Okay.
So auto given in the final exam is auto given is more number of the majority of numericals or in theoretical concepts.
Final exam, 25% will be numerical, I guess. So whatever how you are doing in the assignment, similarly it will be there. So if you add all assignments, how many numericals will be the same kind of percentage you can expect. If you can't do simple problems, you can solve. You can easily score, no issue. Mm. Okay. Okay, let me start the session. Uh, Good evening, all. Welcome for the week 11 PMR problem solving session for the course, NPTEL course, wastewater treatment and recycling. Those who are joined new today, let me introduce myself. I am Saravanan, PhD scholar and Prime Minister Research Fellow of Civil Department from NIT Tiruchirappalli. So, as a part of PMR of TAship, I am taking this NPTEL course, wastewater treatment and recycling. So all the course materials are originally taught by Dr. Manoj Kumar Tiwari sir, and all the PPT credits to him. And this 1 hour every Monday I am taking 6 to 8 p.m. And first 1 hour we are going to discuss the same lecture material what sir has discussed in the YouTube lectures, and another 1 hour we are going to solve the old assignment problems. So we are in the 11th week of this course. So first 10 weeks we have completed most of this first line wastewater treatment. So other next 11 and 12th week we are going to discuss about the recycling part. Okay. So as a glance, I will tell you. First week we have discussed about what is wastewater treatment, why we need to treat, what are the consequences if we not treating the wastewater and disposing as it is in the river or any surface water, what will happen, health hazards, ecosystem damages, and all we have discussed. And later we have discussed since it is required to treat the wastewater, how much quantity we are going to treat. We have assessed the quantity of wastewater that is generated through different population forecast methods, right? So that problems, if you want, I can discuss again. Geometric mean method, arithmetic mean method, simple methods to find how much population in the future, so that we can calculate how much quantity of wastewater generated. In the third week, we have assessed the quality of the wastewater, different quality parameters like physical parameters like pH, temperature, color, odor, chemical parameters like alkalinity, hardness, heavy metals, different nutrients like nitrogen, phosphorus, and biological parameters like fecal coliforms, E. coli, and all we have discussed, right? Then the fourth week we have discussed about the natural purification process of the river streams. So whatever the disposed water after treatment or without treatment, if you discharge in the river stream, how it will treat like different zones like decomposition zone, clear zone, recovery zone, and all we have discussed based on the DO, dissolved oxygen content. So wherever the DO will be less, there will not be any aquatic life, right? So DO minimum should be 4 milligram per liter to for the aquatic life to survive. So this and all we have discussed in the fourth week. Fifth week we have discussed about the treatment options. For that we need to know the mass balance. If we know the mass balance principle or concept, we can able to solve all the treatment problems. So the concept on reactors like batch reactor, continuous flow reactor, plug flow reactor, we have discussed in the fifth week. So in the sixth week, we have discussed about the preliminary and primary treatment. That is the screening, grid removal, and primary sedimentation tank. Later, we have discussed about the secondary treatment, that is ASP, activated sludge process. In that, various kinetic parameters we have discussed. Kinetic parameter in the sense how the system reacts to the microbial conditions, or both the physical as well as the biological kinetic parameters we have discussed. And in the upcoming weeks, we have discussed about the anaerobic treatment. That is anaerobic digestion and all. And then later we have discussed about the sludge management, because all this primary and secondary treatment produces sludge management. In the sense we have discussed about sludge collection, drying, dewatering, conditioning. Finally, after drying, how we are going to dispose in the incinerator plant or whatever we are going to use the dried sludge, that and all we have discussed in the sludge management. Later we gone with the tertiary treatment. In the tertiary treatment, after secondary treatment, some Dissolved inorganics will be there, like salt content and all. There we have discussed a lot of tertiary treatment approaches like desalination, reverse osmosis, that is a membrane, and electrodialysis, different kinds of tertiary treatment we have discussed, and AOP, advanced oxidation processes, and this and all we have discussed in the tertiary treatment. And the last week we have discussed about um, me. One second.
Sir, go ahead with the modern technology.
Yeah. So last week we have discussed about the modern technology in the sense SBR, MBR, MBBR, and SBBR. So these four technologies recently they have developed in the even municipal treatment and as well as industrial wastewater treatment. We have discussed about SBR, SBBR, MBR, MBBR. So SBR is sequential batch reactor similar to ASP, how we did in the batch reactors. Then SBBR is the same SBR, how the what we have, that plastic media or any kind of inert media, how it's behaving. That bacteria will attach to the media and it will grow. SBR is suspended growth. ASP is also suspended, but ASP is aerobic suspended continuous treatment system. SBR is same aerobic, same suspended, but it is a batch system. All the sedimentation, treatment, reaction, settling, everything happened in the same reactor. And then SBBR, similar to that SBR, we have a inert media in suspension, but the bacteria are attached to that. MBR is membrane bioreactor. We are filtering after treatment, same like ASP, we are filtering the effluent. MBBR is same to MBR, we have a media, right? Then we have some more advanced systems like UASB and all we have discussed. This week we are going to discuss, let me open lecture material. Yeah. So this week we are going to discuss about, yeah, concept of wastewater reuse and recycling. This is mostly theory oriented. How we are going to recycle, where we will dispose the treated effluent, what are the different what we say direct, indirect methods of recycling the treated wastewater. So mostly theory oriented, mostly based on the standards. So if you have to dispose for a lawning purpose or bike washing or a vehicle washing, anything, if you have different standards are there. If you want to use for agricultural purpose, what is the standard requirement? If you want to use for vehicle washing, what is the requirement? So some different standards we are going to discuss today. Okay, now what is wastewater disposal? Why say no to wastewater disposal? We all know we have a water pollution. So if you again pollute the resources, what we are having only uh, a small quantity of fresh water for us, right? So we should not pollute the available fresh water. And again, if you discharge the treated water in the fresh water, then again it will be contaminated. So that is a major problem. We have a water stress, that's the word called stress. So we are having a water stress, that is the demand. So increasing demand again enhances the stress on the freshwater sources. So for that we have to follow this kind of uh, 3R patterns, like reduce, reuse, recycle, 3R pattern in the water systems. So reduce in the sense we have to first reduce the quantity of waste generated. So before generation itself we should know whether this tap is need to be opened or not. So that and all we can do for reduce purpose. Wastewater generation itself we are reducing. Okay, once it is generated, without treatment, how can we reuse? That is called reuse. With or without treatment, we can think about it. Recycle is after treatment, the reclaimed or recovered water, what we can do. That is called recycling. You got it. You got the difference between reuse and recycle. So I am washing my face in a wash basin, and the water that is collected below, that can be used for toilet flushing. So this is reuse without any treatment. But I am using it in the STP after treatment. I mean filtering, sedimentation, everything happened in the septic tank. In that, the effluent is going for the gardening purpose. That is called recycling. So water effluent coming out of the septic tank is a recycling purpose. Directly from a wash basin to a toilet flush is a reuse option. You got the difference. So, and if I'm not using the fresh water, that is called a reduce. So I'm not using for this purpose. I'm reducing the quantity. That is called reduce. You got the difference? 3R is major term in wastewater recycling or water recycling. So why wastewater reuse or recycling? Because it helps in pollution control, serves as alternate water resources. So we are again reducing the same quantity of why we need to use the fresh water for toilet flushing. So again reduces the again it will reduce the fresh water that is available to us. So we have to think about the pollution that is going to happen, also the quantity of water available to us. Both are interdependent. So that will reduce the stress on the freshwater resources. How recycling wastewater requires appropriate treatment before its intended use, and it also costly. That's why many people are thinking recycling means what are the cost I am going to invest? What is the treatment I need to do before recycling? That and all a major question, right? So cost again plays a major role here. So what are the driving factors for wastewater reuse and recycle? Water availability. You think about villages. People are having they have to walk for long distance to fetch water instead of tap water, right? So the water availability is less, so they will reuse or recycle a lot. So this again interdependent on the water availability, water consumption, meeting water demand. So people are low income group, high income group, how much the water they are consuming, that also required driving factor for the reuse and recycling. Water quality, so if your degree of treatment is good, then I can use even for higher purposes. Even wastewater they are treating and using for drinking purposes also. If you can able to remove even pathogens, then we can try for drinking also. That much water quality is required. That is a driving factor for the wastewater recycling. So again, if you think the population, water scarcity, freshwater availability, and its cost, and easily accessibility of the water. So like Singapore, if you take for example, they are not having access to the water. So now whole research on Singapore is happening on desalination, treating the marine water for their drinking purpose. So accessibility plays a major role. If you can't access fresh water, you have to think about the wastewater as a source, right? So regulatory requirements, wastewater discharge cost, environment and social responsibilities, that and all plays a major driving factor for wastewater recycling and reuse. Finally, the opportunities. So think about how can we reuse. Two purposes. One is indirect reuse, other one is direct reuse. Think about indirect reuse. I am after treatment, I am discharging the treated effluent into the groundwater for recharge, or I am discharging the treated effluent into the river body to for somewhat more treatment, or later I can use that for fresh water as a fresh water. So this is the indirect reuse. You got it. Disposal in groundwater or surface water. I will show with the picture in the next slide if possible. And the direct reuse is without adding to the resources, I am directly using for any purposes. Then it is called direct reuse. Treated wastewater is channelized for some purpose. They're again connected with the two separate categories: contact users, non-contact users. Contact users in the sense people will be in contact with that reuse purpose, like drinking, bathing, and all. Non-contact reuse is somewhat in gardening or vehicle washing, that and all. But without adding to the groundwater, I am directly diverting to the application part. That is direct reuse. If I am directly converting into to the groundwater or diverting it to the river, then it is the indirect reuse. You got the difference? Yeah. I will show with the picture. Maybe the picture is that is easy to understand. Yeah, here, see. This concept I will explain now itself, so you can easily understand. Indirect potable reuse, IPR. Portable in the sense water that can be supplied for human purposes. So after what water I am collecting from river, I am treating in the water, not wastewater. Water treatment plant, and then I am supplying. That is called potable water. Potable water I am supplying to the community. So that potable water reuse I am indirectly doing means, see, the wastewater that is water that is collected, treated, supplying to the people after use. These people are sending the wastewater to the wastewater treatment plant. So we can do conventional wastewater treatment, advanced wastewater treatment, anything we can do, directly sending to the potable water treatment plants. That is the indirect potable use. Or if I am diverting it to the surface water reservoirs or groundwater reservoirs, that is indirect. After that, I am again taking and using it for blending with the wastewater. See here, the direct reuse. Without sending to the groundwater or surface water, I am using for any purposes. Direct treatment and then using for any purpose. That is called DPR, direct potable reuse. You got the difference? So without any recharging, I am directly treating and using. Here, treating and putting it into the groundwater or surface water, then taking for use. Yes. So various sectors we have to think about the treatment. First is grey water recycling. Grey water, you all know that four types of wastewater, four color codes of wastewater we have discussed in the first lecture. Grey water is water that is coming from washing machine, dishwashers, and bathing. It will not have any much organics, right? Simply, it's a simple treatment we can do. That is a grey water. And yellow water is water that is coming from urinals and toilets. Toilets in the sense brown water. Combining all this will be black water. This is what we have discussed in the first lecture, right? So grey water is having no much contaminants, so containing almost no pathogens, little ammonia, because food waste will come, from dresses, cloths, some impurities may come, so that is a little ammonia it will create. So easy to treat with the conventional wastewater. So we can collect it in the septic tank, and then through the sand filter we can pump out, use for any groundwater recharge or planting we can do. Think about municipal sewage recycling. Municipal sewage contains, it will not have any grey water. No need for separate grey water collection system, because it's directly from the whole mixed waste. That is grey water plus brown water plus yellow water, everything. So it requires high degree of treatment because it contains high organic matter and pathogen contamination. Why pathogen? Feces, human feces may come in. So it needs high degree of treatment. After treatment, we can also think about drinking purpose also. Then industrial effluent treatment. See here, reusing for other purposes at the plant site itself. Because most of the industries, they are now following, as I mentioned, zero liquid discharge (ZLD) scheme by the government. So Tamil Nadu, it is mandatory. So all the industry, they have to treat their water and they have to use in their own plant for some other purposes. So tailored to meet the water quality requirement, they have to treat based on their requirement. Correct. So that is industrial effluent recycling. Then stormwater or rainwater, you all know that can be collected. It's already clean. If any sediments will be there, that can be settled in the sedimentation chamber, and you can think about keeping it in the tank or groundwater recharge or aquifer recharge. Anything you can do, and use it later for irrigation purposes. If you want, you can also do for disinfection and supply for drinking water also, because it's a pure rainwater. Yeah. So as I mentioned, reuse options, reuse without treatment or reuse with the treatment. Reuse without treatment, you can think about small scale agricultural applications. That is a old philosophy. Small scale agriculture without treatment, you can do like, I am directing my kitchen sink water into my garden. That is a simple approach, right? Without treatment. So potential problems are some washing, dishwashing. I will use some soap. So that disinfectant or surfactant may have a hydrophobic property, water repellent property, that will affect the plant growth. High amount of sodium, because I am using dishwasher or any cloth washing water that have sodium will be there. So that will have arise the sodium absorption ratio of the soil. So that will be, soil becomes saline. So for presence of coliforms, if you see, that will, if any microbial contamination like coliform, E. coli if present, like if I am diverting my bathroom water into the garden, the E. coli may directly attack the plant and it can be transmitted into the harvested food crops. So that is a problem. But new philosophy is for domestic application, non-contact applications like toilet flushing. As I mentioned, the sink water can also be directed, or a wash basin water can be directed to toilet flushing. That is non-contact application only. But the problem is clogging. If the food particle after washing from the plates, that can clog the pipe easily, and layer of biofilm, because it will have a organic, so bacteria can grow in the pipeline itself, it will clog, may cause skin disease, because if any contact on the skin, that will affect. So that is problems of reuse without treatment. But if you think about reuse with the treatment, you can go off any applications like irrigation, non-contact domestic application, contact domestic application, industrial application, recreational application like park, lake, pond, streams, fountains. So I had seen in Bangalore, they have a treatment plant and the effluents are directed to the lake, and people are going for walking around the lake. So it's having a fresh it's ecosystem, like algae will be there, so whole fishes will be there. It's a kind of rich food chain ecosystem. And discharge to the surface water, groundwater recharge, we can think if it is treated. See, another sector is the sector from the sector for wastewater reuse. We have to think about the where the wastewater is coming from, like municipal wastewater, storm water, grey water, industrial wastewater. We have discussed that. Where we are going to use, first one is agriculture or aquaculture. So here we can think about irrigation of non-food crops, that is limited treatment. But if we think about good treatment, good degree of treatment, we can go for edible plants like food crops. Non-food crops are like flowers, some kind of non-food crops we can think about. But food crops we need a good quality of treatment. Then only we can apply to the agricultural land. Then think about the landscaping and recreational areas, and water use in the aquaculture and fish farming we can do. But the risk is high concentration of salinity, trace elements, excessive chlorine that can easily kill the fish. Also, it will be harm to the uh, crops. So, increase the soil salinity, and trace element and toxic chemicals may bioaccumulate. As I mentioned, any heavy metal that is present in the soil or through the wastewater, it may enter into the plant body and it will accumulate on the crops. So if we eat the same crop, it will accumulate on our body. That is called bioaccumulation. From small fish to big fish to whale, humans to again to the soil. So this is a food chain. Bioaccumulation is happening. 1 gram will become 10 gram because it will eat 10 fish. Then 10 fish will 10 fishes if we are eating, it will be 10 power 10. So it will be accumulating, bioaccumulating, and potential risk will be there. So if you think about municipal sector, that is a household level, we can think about flushing. That is the first option, because without treatment or with the treatment, we can think about toilet flushing. So that is for non-contact users. Also, we can think about augmenting drinking water supplies. So if the social acceptance is okay, after high degree of treatment, we can think about the drinking water supply purposes. Other urban users, kind of public park, recreation activity, commercial users, ornamental landscape, fire protection, we can do. Industrial sector, as I mentioned, for their own purpose, they can do if the degree what they required is attained, or else they can think about cooling systems, boiler feed water, floor washing, and fire protection. Fire protection, any water we can do after simple kind of treatment. Then think about the environmental sector. We can use for artificial groundwater recharge or augmenting stream flow. Both are related to groundwater and surface water. So this is a indirect reuse pattern. So we can directly dispose in the groundwater. So after treatment, that can recharge the aquifer, or you can put it in the river that can increase the flow. In the groundwater, in the flow itself, it will automatically regenerate. That is self purification. It will do. So what are the requirements we need to reuse? If you see the statistics, two-thirds of the sewage is discharged untreated. Think about this. In class 1 cities, we have 11,153 million liters per day of treatment capacity. But that can help only 68% treatment. Where about the other 32? And if you think about class 2, 92 is not treated. Similarly, there is a capacity gap. Red color is the gap. If you think about the whole, 70% is not treated. So where we will go for this 70% untreated wastewater, where it is going? So two-thirds of the wastewater is discharged untreated. That is the problem. So if you take small statistics, I am taking 100 liter of water a day. 80 to 90 percentage of the water that is consuming, that will come as a wastewater. So I am consuming 100 liters, 90 liter will come out as a wastewater. If you say 10% will go off as a loss, I can say 80 liter it will come as a collection system untreated. Out of that, 70 to 80% can be reclaimed after treatment. So I am drinking 100 liter, 90 liter will come out as a wastewater, 10 liter may be a loss. So 80% will be collected and treated. Out of this 80 liter, 80% will be reclaimed. So minimum 70 liters I will get after treatment. So for a person itself, I am getting this much, means think about the 100% and how much quantity we are drinking. So I mean we are consuming and we are generating as a reclaimed water. So to fulfill our major purpose itself, we can rely on the recycled water. Why we have to think about again the fresh water, right? So that need a degree of treatment we need to think on. So ESBSP, they have a category for urban reuse, for agricultural reuse. What is the restriction they have to follow? Similarly, which type of treatment is required for which purposes. If you do only primary treatment, we can't do anywhere like sedimentation alone. If you go for secondary treatment, we can think about surface irrigation for non-food crops, groundwater recharge. If you do pure advanced treatment, we can think about toilet flushing or vehicle washing, food crop, because this all will come as a contact. After that, we can think about indirect potable reuse also, like groundwater recharge and surface water recharge. So what are the stages of wastewater recycling? After generation, we have to collect, we have to transport to the wastewater treatment plant. After treatment, we have to transport to the reuse option, and at the designated reuse option, we have to apply. So these are all the steps. First, collect the wastewater generated, then transport to the treatment plant. After wastewater treatment, we have to transport to the reuse part. There we have to apply based on the quality. Okay, so consider the water use plan. It's based on health, economy, social acceptance, finance available, impact on the environment, market feasibility, institutional feasibility, and all. Technical feasibility is again a major thing. How much treatment we can do and all, right? So based on this, we can say this is a sustainable project plan. So we need to have a sustainable project plan for the reuse. So this we have already discussed the direct and indirect reuse option. So for direct and some example, if you see Belgium, they are doing returning to the aquifers. In India, they are blending with the reservoirs like rivers. They are mixing after treatment. So different countries, they are again blending with the one aquifer or to the surface water, the treated effluent, right? Similarly, again, if you see the guidelines in different countries, we have to treat the wastewater. What are the parameters we had seen? That and all need to be treated, like physical contaminants like turbidity, color, suspended solids, chemical like carbonic pollutants, BOD, COD, DO, metal, nutrients. DO is not a pollutant, that is requirement. Then biological contaminants like pathogens, algae. In pathogen itself, we have E. coli, helminths, eggs, that and all viruses we have to treat. Emerging pollutants, that is a major thing. Again, nowadays we are seeing pharmaceutical wastewater, personal care products, pesticides, whatever the pesticides we are adding to the agricultural field during rain, it will again come up with the surface water that need to be treated, right? So we have a regulatory water reuse guidelines, international guidelines. We have WHO and EU guidelines, and national specific. We have a US EPA, national guidelines, state level requirements, and other requirements. So if you we have a 4 volumes of WHO guidelines for wastewater reuse. One is for excrete and grey water. That is wastewater regulatory aspect. This is for agriculture. This is for aquaculture. Like that, we have 4 volumes of wastewater reuse guidelines. I will upload this in the reading material. You can think, look into. And who again have a guidelines for that is a proper framework, health component and implementation component. So health wise, we have to think about the risk assessment and health protection measures. For implementation component, we have to think on monitoring. How can we monitor the daily reuse pattern, and institutional oversight responsibility requires a system documentation. So you can see the parameters like pH, TSS, TDS, how much it should be for different categories. Like they have A, B, C, D category. Based on that, we can do the reuse applications. So USEP and USAID, they have a guideline. USAID, again, they have a guideline on what are the treatment we can do. Based on that, the reclaimed water should have a quality of less than this much BOD, less than this much turbidity, so that we can use for this much reclaim options. Like weekly, we can do the reclamation or anything. This is documentation purpose. Every week, we have to monitor the pH, BOD, turbidity, and all. Continuous monitoring. So all the guidelines we can think on and to follow the reuse applications. So see again WHO microbial quality guidelines. So if it is having less than one nematodes, we can go for irrigation of crops. For irrigation of cereal crops, it should also be less than or equal to one. And fecal coliform, there is no standard. For localized irrigation of crops, there is no need of any guidelines. So it's ABC category for the agricultural reuse. For irrigation water, again they have a guidelines for the trace metals. For pathogens, they have guidelines. For different parameters, they have guidelines. For trace metals, for microbial standards, different countries are having different. Different heavy metals are having different limits. Here, different countries are having different limits for total coliform and fecal coliform. So, these are all for your understanding. So, think about how much treatment we need to do. So, if you are working, your research is on any one metal. I am working on chromium treatment. So, I have to think the wastewater should all at least have less than zero point 0.1 so that I can think about irrigation water purpose. So, if your treatment should achieve this much quantity at the outlet, you understand? So, that is based on WHO guidelines. Then operational conditions, you see, suspended solids in the reclaimed water, that can be a problem on clogging. So if you are not treating the suspended water solids in the wastewater properly, that will affect as a clogging agent in the reuse purposes. Similarly, pumping capacity redundancy in municipal waste system is installed in event of a failure. So like you are distributing water, I mean wastewater to the treatment plant. After treatment, the treated water can be pumped back to the what we say the community, but the community to the STP will be on gravity. Again, from STP to the community, it should be pumped. So there should be a proper pumping system, otherwise it will get failed, right? And additional regulatory standard, because if you are using for agriculture in edible crops, then it need to be properly documented, and all the parameters need to be considered. Like secondary quality reclaimed water cannot be used for agriculture, and that also have some aerosols if you apply, because whatever the particle in the water when sprayed, that will emit as a aerosol. Aerosols are the solid particle contaminant is present in the air, that will again come up with the droplets of water, that is called the aerosols. That will be a problem, again air pollutant. So regular communication between the end user and the reclaimed water supplier, this networking is the major requirement. See again guidelines for irrigation water quality, salinity, how much it should be. So that's a major thing. For wastewater to be used as irrigation purpose, TDS is the major factor. TDS, that is the salt content, and electrical conductivity and TDS are again interrelated. So how much salt, that will affect the salinity of the soil. So for the boiler in industry, I am using the fresh water for boiling purpose. Again, the wastewater, if I am using treated water, if I am using the boiler, again I need to think about the salt, because if salt is present at high temperature, salt will deposit and it will have an incrustation problem. So TDS, alkalinity, conductivity, dissolved oxygen are a major part in the boiler reuse. See the USEPA guidelines for category-wise reuse for urban, agricultural, impoundments, environmental reuse, and industrial reuse, and indirect portable reuse. Finally, centralized and decentralized recycling system. So, if you are thinking about recycling, I am in a city. My STP is 10 km away from my city. You got it? It's collecting all the wastewater from the city. But instead of that, if I am having a local decentralized wastewater treatment plant, how can be it's easily treated and reused in the same purpose? Because sending from city to 10 km outside outskirts of STP is fine. But again, treated water supply, again it should travel 10 kilometer to reach the city. That is the problem, right? So that need to be taken care. For distance consideration, we have to think about the centralized and decentralized wastewater management. See, all the wastewater from the city are collected to the STP on the outskirts of the city. But if you have a decentralized approach, this cluster may have a single STP. This all cluster can supply here. This cluster may have a single STP. You got it? So based on that, you can think about decentralized approach. So collection, treatment, and reuse of wastewater is done at the nearby point. Then it is a decentralized management of wastewater. But centralized system consists of a sewer network to collect all the water from the city, and it will be going to a centralized place for treatment. Right? For a treatment plant is on the off-site location. Reuse of the treated wastewater should again go a fair to the origin point. That's the problem here. In here, you see, all are having a separate STP, and again after treatment, I can reuse here itself. So wastewater is collected, treated, and reused at the nearby point. That is um, collected and okay here collected for many wastewater producers, and it is sending to the STP offsite the location. Right here, historically, it's a common strategy, because Earlier, people are in the clans. Each clan have a separate STPs or the treatment system and apply to the different scale, like large scale, small scale. Based on that, anything you can think on the scales, you can modify the chart. And see the scale of decentralization. If it is a centralized management, only one for the whole city or a catchment area. But the decentralized management, we can have a small scale for individual house, or for the large scale for apartment, or medium scale for the apartment, large scale for a community. Which one is more suitable based on the what we say, the population and the quantity of wastewater generated, right? The advantages of decentralized system are it can protect the public health and the environment, meeting the increase in the demand, reducing the pressure on the water source, because again treated water they are using, no use of water as a transportation medium, because again from for that much distance to from see the first house here, from here to here, if it come, it need to have a high water pressure to transport the wastewater from here there to here. But here there is no requirement of external pressure, and the possibility of gradual development and investment, availability of many case specific technologies. So the reason place the technologies are nowadays available. As I mentioned, SBR we can install in a small apartment, small space we can do that. So the aspects you have to think about: the physical aspect, volume, site availability, feasibility. Technical aspects: what are the treatment technologies available, and its sludge management. Whether I can able to manage the sludge in the site itself. That and all a major concern. So if you don't have a space, if you are in a Trichy kind of developed metro city or a Chennai kind of thing, you can't think about decentralized at the same point. But if the space is available, you can think on. Energy aspects, combined energy footprint, you have to check for both the options and compare. The end use aspects, where we are going to dispose again. For agricultural land, it is available inside the clan, then it is good to have a decentralized system. Social aspects, these environmental aspect and institutional aspects are major thing. Social aspect, as I mentioned, human settlement. If you have a STP in the center of the city, the people will complain. Last month we had a court case for the other problem given by a nearby municipality. So we have inquired there. We went there and we found the problem of order, because earlier the STP was outside the city, but due to the development of the city, people are moving and settling nearby the outskirts. Now it become the whole city. Now if you see, the STP is nearby his house, so he is complaining. So that is the problem. Aesthetic or public acceptance, willingness to pay, that and all a major problem, right? Then, if you think about the management aspects, usually left to the house owners, because if STP is there for an apartment, the apartment people have to pay for the treatment process, and whatever the treated water they can reuse. So the amount, the financial part is left over with the homeowners. That's the problem. If it is a common STP, we can do, the municipality or the whole community can pay. But it is essential to develop policies, program guidelines, and the institutions to ensure the proper design and construction, operation and maintenance. We do have to have a policy framework, and the management system include funding, public involvement, awareness. Because we need to know, instead of sending our wastewater to that much distance, why can't we do here? Simple acceptance, public acceptance is required. The advantage of decentralized system is it does not require large investment, no need of large pipe and all, right? Then easier to achieve high removal rate, low energy and maintenance system, less hydraulic impact, higher preferable to local scale, and consider green and sustainable solution. That is a major part. Integrated into flexible wastewater treatment. But the disadvantage is treatment efficiency. Because if it is a big STP, if some part is not sending water also, it will work better. But in a small scale, the fluctuation will be very high. So that fluctuation we have to tackle. It can be harder to document the treatment efficiency. Every day it will vary, and the risk of failure of some units, O&M become additional burden to the owner. I can't bear all the cost of treatment, and high risk for the public health. It's nearby, so anybody can get affected. So all this point need to be taken care before choosing the decentralized system. So the proper treatment and without any affecting the human health is the task here. So the recent trends, if you see, enforcement of reuse guidelines already given by the government. So we have to think about that for apartments or a small community level. And several apartments in major cities already adopted this type of decentralized system, and they are reclaiming the water can be used for gardening, street washing, and other purposes like vehicle washing and all. And the CPCB, they have enforcement on the industries to follow the zero liquid discharge policies. and overall the relatively easy decentralized system is relatively easy compared to the centralized system and more popular than the conventional centralized wastewater management policies. You got it? So today we got a whole idea about what is the treatment required for different options of recycling. If it is generated from industry or a municipal community or a grey water or a storm water, what can we do? How can we reuse for agriculture, aquaculture, for the municipal in domestic? How can we reuse for the industry? How can we reuse? What are the WHO guidelines, US EPA guidelines, US EID guidelines, and CPCB guidelines for the industries? We have discussed. Finally, we have a direct and indirect reuse and a centralized and decentralized system we have discussed in the whole lecture. You got it? If you have any doubt, please unmute and ask, or you post it in the chat box. I will ready to answer. And otherwise, I will go with the problem solving session. So today, fully it's of theory and the reuse part, recycling part. You got it? Yes. Okay. Please post the answer in the chat box. I'll read the assignments. It's only 20 problems. We can finish it off in half an hour. Yeah. So the first question is, let me take the pen. The most critical stage for effective recycling or reuse of wastewater is most critical stage. See, water reclamation through treatment of wastewater, water use reduction by adopting water saving practices, preventing transport of water to offsite, storing wastewater for continued reuse. Which is the critical stage? From down I will come. Storing is not a problem. I can store. Preventing transport of wastewater to the offsites, that is also not a problem. Water use reduction by adopting water saving practices or water reclamation through treatment of wastewater. Which one is correct? Which is the critical stage? You could be able to relate this question. Which is the critical stage for effective recycling? Or reuse of the wastewater? Okay, let me go with the answer. Water reclamation through treatment of wastewater. Because see, here the main problem is water reclamation involves high processing to produce the reusable wastewater. That's why we have to, that is the major task in the wastewater reuse part. We can easily reduce, but with the generated wastewater we have to reclaim and reuse. That is the part in the reuse and recycling, right? So you think about the wastewater reclamation part. How to get the water from the wastewater. The second question is, level of treatment required for industrial effluent recycling depends on how much treatment we need to do based on level of pollution in the industrial effluent generated, water quality requirement for the plant reuse if we want agricultural or domestic purpose, what is the treatment requirement, regulatory mandates. So I think the answer is, can you post ABCD something on the chat box if possible? Yes. So the answer is D, because all this seems to be the requirement for the level of treatment. Yes. So the third question is, gardening and lawn irrigation with treated wastewater is an example of. I am treating water that is wastewater generated STP after treatment. I am using for gardening. So this is the so direct or indirect first. If I am after treatment, if I am discharging into the groundwater for recharge or for the surface water for recharge, then it is direct or indirect. The first one is direct. This is indirect. Okay. So the answer is to the garden is direct. Is this a contact reuse or non-contact reuse? Is this going to happen anything with the human contact? No, right? So it's a non-contact direct reuse of wastewater. You got it? Yes. Okay, nice. So it's a non-contact. Okay, fourth question. Municipal sewage recycling typically includes municipal sewage. So we have four sectors: stormwater, industrial wastewater, municipal sewage, grey water. So municipal sewage contains treatment of and recycling of combined grey water and stormwater, but not the black water. Treatment of recycling of combined grey water and black water, but not the stormwater. Treatment and recycling combined black water and stormwater. Stormwater will not come in municipal, right? So and the stormwater is will not be correct. As well as stormwater will also be not correct. So our answer is treatment and recycling of combined grey and black water. There is no separate system for black water, grey water, right, in the municipal. So this is correct. Treatment and recycling of combined grey. See, no need of separate grey water collection system. All the grey water as well as the black water, black and grey will merge and treated in the municipal sewage recycling. Yes, correct. B is correct. Yes. Next. Unless there is a specific requirement in the industrial reuse, which of these pollutants are typically not removed during treatment of wastewater for general reuse and recycling? So for industrial reuse, unless required, I will not treat this. Which one? BOD and COD need to be removed. Suspended solids I will remove anyway. I think dissolved solids typically not removed during treatment of wastewater for general reuse purpose. Because dissolved solids removal requires advanced or tertiary treatment. Suspended solids can be removed in primary. COD and BOD can be removed in secondary. But this requires advanced treatment. So dissolved salts will not be removed unless required. If I want for a boiler feed, I will remove the salts also. Otherwise, the salt will incrustate the boiler, right? So boiler feed water quality requirement we have to think. So advanced I will not go unless it's required. You got it? Okay. See, this is what I have mentioned. Industrial requirement, first it will see TDS if we need for any steam or boil water. Okay, ZLD is a concept applied for ZLD means zero liquid discharge. Please remember that is a major concept. It's required for municipal sewage recycling, stormwater and rainwater reuse, industrial effluent recycling, groundwater obstructing for irrigation, which is correct. ZLD is related to yeah. See, so industrial effluent recycling we need to follow zero liquid discharge. So after recycling, it go for multiple effect evaporator. MEE we will say. So we have to think about full treatment and after treatment, whatever the water left that will go to the multiple effect evaporator. In that, it will get evaporated at high temperature. So pure water will go as a gas. It will run the turbine and it will generate energy. And also the water can be reclaimed as a pure water. Salt or whatever the impurities present that will be solids will be retained here. So again, the energy that is present in the water will be used to heat the incoming water again, right? It's having some energy and going, and that energy will be used to heat the next energy. So one time energy induction will be fine. Next time we can use the same energy. That is called a multiple effect evaporator. So again and again I can have a chamber and I can feed the new water. But the earlier heated water will be used to heat the next chambers. So this is all they are following. Finally, no liquid will come. Only the salt deposition or whatever deposition we can use. And the energy also we can save. There is no wastewater to be disposed. That and all followed in industries. Right? Yeah. So CPCB enforces ZLD for the industries. Okay, as per USEPA, USAID, reuse applications, guidelines recommended disinfection treatment stages. Where we need disinfection? Urban landscape irrigation, irrigation of food crops not commercially processed, irrigation of food crops that are commercially processed. For food crops itself, we need disinfection, right? We need disinfection. Disinfection is to remove pathogens, to remove microbes. We need to disinfect. We need no need of any microbes. So disinfection is required before applying for food crop. Whatever commercial and non commercial, food crop means it need to be disinfected. Both are correct. Also, urban landscaping. As per UCPA, all need to be disinfected. See, for urban reuse, agricultural reuse, commercial or non-commercial purpose, all need to be disinfected. You got it? That guidelines mandates if it is a primary or secondary or tertiary treatment that are not matters. Disinfection required. Right. Eighth question. For reusing treated wastewater for drip irrigation, the required degree of treatment is drip irrigation. You all know drip irrigation, right? In the agricultural land, instead of putting making the water to flow through the channel, I am having a pipe with small holes. So the water will come drop by drop through the holes. So that will have a continuous irrigation as well as it have a water can be saved, but the plant will also grow properly. So that's a drip irrigation. But for drip irrigation, the wastewater, if you want to use for drip irrigation, what is the required treatment? Preliminary, primary we need to do. Secondary is enough or tertiary we need to go? I think for irrigation, secondary is enough. If you want to reduce TDS, we can go for tertiary. I think that drip we can go with secondary itself. No. Salt. Salt is the major issue. Tertiary is correct. Yeah. TDS we have to remove before applying to the soil. Because salinity is the major problem. Soil will become saline. You can see some of the agricultural field, they have a white deposit on the soil. That is due to the salt content in the untreated wastewater. Or from if you are using groundwater also, it's the problem. See, for using in the drip irrigation or irrigation, tertiary treatment is required. Okay, they have two statements related to decentralized wastewater management, which is correct. Statement 1. Decentralized wastewater management is always cost-effective solution. Is it correct? For wastewater management over centralized system. Statement 2. Further, decentralized system do not require long distance transport of the wastewater. Is it correct? Yeah. Because decentralized wastewater not required long distance, it has a reduction in the cost. So it's saving the cost. So both are correct. Statement 1 is correct. Statement 2 is both are correct. You got it? Because statement 2 is the good assertion for reason for the first statement. Yes. Related to decentralized, the major thing is we are not transporting for longer distance after treatment. Why? Statement 2 is correct, okay. Why statement 1 is not correct? Decentralized system is always cost effective. Okay. The word always solution for wastewater management over. Okay. No. It's based on the community. Which is better? Centralized or decentralized? We have to think. Statement 2 is correct. Long distance transport we are reducing, but we can't say always decentralized is good, cost effective. Because the O&M will become additional burden to the owner. That is the disadvantage of the decentralized system. So that is a major problem with the decentralized system again. So statement 2 alone correct. Sorry, please correct it. Statement 2 alone correct. Okay, 10th statement. Based on the reuse option, which is good. Which is the good definition. Direct portable reuse. Indirect portable reuse. Non-portable reuse. Non-portable means not for any human application. Human application means human consumption. It may be washing or anything. Indirect means to the aquifer or to the groundwater. See where it is, using treated wastewater to recharge aquifer, used for municipal supply later. So that is the indirect. Direct is blending treated wastewater with the surface water before water treatment plant. No. Direct supplying treated wastewater through one of the dual supply line in the apartment of the residential complex is A. 1A, 1A to be connected non-potable reuse. We are not using for blending treated wastewater with the surface water before water treatment plant. Okay. That is the indirect. Okay. So BC to C, 1A, non-potable is using treated wastewater to recharge aquifer, which is used for municipal water supply. BC 3B, no, 1C. Direct potable, blending treated wastewater with surface water before wastewater. No, direct is, wait, there is a mistake. 2B, indirect is recharging aquifer used for water treatment. Okay, indirect is recharging, then it's going to the water treatment before. Okay, indirect is correct. Then CA, supplying treated wastewater through one of the dual supply line in the apartment of the, okay, they are not using for anything, just supplying to the residential complex, just transporting through the residential complex dual line. So 3A is correct, and 2B is also correct. Then blending treated wastewater with surface water before wastewater treatment plant, that is not A, there is a mistake. Blending treated wastewater with the, where it's going, other type of reuse and discharge to the receiving water bodies. That may be any uh, river or lake that where the potable water treatment is taking the water. So we can say that as a direct. You got it? So the first option is we are not using anywhere, simply taking the water through the dual supply lines. That is a non-potable reuse. Second, using treated wastewater to recharge the aquifer, that is a indirect. Aquifer or any surface water, that is a indirect. But blending wastewater with the surface water bodies before water treatment plant, directly they are using without any recharge of aquifers or the surface water body, directly into that water treatment plant. Okay, now you understand the direct purpose, without any mixing of surface water body or to the groundwater bodies, directly to the WTP. So that is a direct portable reuse. Okay, now it's clear. You understand? 1C, 2B, 3A. Is there any confusion? Please be clear. Wastewater is collected from a community wastewater to the STP after treatment. If it is going to the groundwater recharge or surface water river or something, that is indirect. That is what given here, aquifer recharge groundwater. Or from the STP, if it is going to the water where the waste WTP is taking water, then it is a direct use. And after treatment, it is coming to the dual line to somewhere, then it is called non-potable use. For somewhere they are using non-potable. We are not coming again taking to the community. We are sending somewhere. Okay. From the picture, if you see, what are the following questions they are asking? Which are the following is a case of agricultural reuse, not recuse, reuse of treated wastewater? Which is agricultural reuse? Where is the agricultural form? Here. Okay. For the river, for the agricultural purpose, they are taking directly the water from the river. 7. Is this correct? It's not the reuse, right? Direct water. So correct, not correct. From wastewater treatment plant, they are taking the water to the agricultural field. Is this reuse? Yes. After treatment, they are reusing in the agricultural form. So 2 is correct. Only link 2. 7 is not correct. 7 is not correct. 2 and 3. 3 is where is No. They are putting it in the groundwater, and then after groundwater discharge, it's maybe taking. So that is not a direct reuse. They are not taking to the agricultural soil. Okay. So only link 2 is correct. You got it from the picture? Okay. Second question in the same
So,
picture
sir, can you explain that?
again. Yeah. This question, this picture.
Yes, same picture, so can you explain?
Yeah. Erase all link. Okay. See, they are asking which they given the various supply uses and disposal are shown in the figure. Linked with the ROs. They have a number for each ROs. So they are asking which are the following number is a case of agricultural reuse of treated wastewater. So they are saying agricultural reuse. So I have to search for agricultural field. This is the agricultural field. So it's getting water from 7, the link 7 and link 2. What is link 7? The river that is flowing, the water is taken from the river. Is it correct? A reuse option? It is a direct application. There is no treatment or no wastewater. It's taking the fresh water. 7 is not correct. If you think on 2, from the wastewater treatment plant, after treatment, the effluent is coming to the agricultural field. So 2 is correct. Agricultural reuse of treated wastewater. So only link 2 is correct. 7 is not correct. Think about 3. Where is 3? After treatment, they are putting it into the groundwater. It is recharging the groundwater. That's it. It's not reaching the agricultural field. So 3 is not correct. You got it? It's also wrong. Only link 2 is correct. You got it? Okay. See the second question in with the same diagram. Which of the following link depicts a case of direct potable reuse? Direct potable means after treatment I am using for the community. See, the city is here. Where the city is taking water from the river to the water treatment, not the wastewater, water treatment plant. So fresh water it is taking, it is supplying to the community. So 4 and 6 are not a reuse option. Where it's getting from 5. From 5, it is getting from uh, the groundwater. It is the correct option or a well. Well or groundwater, it is not reuse, right? It's directly taking from the groundwater, it is directly taking from the river water. So both are not correct. If they are saying direct potable, if the wastewater treatment plant is connected to the city with a link of 9 or 10, that is correct. Direct potable. So 5, 6 are not correct. 1 and 3 are not correct. 4 and 3 are also not correct. So none of the links shown in the figure is direct potable reuse. Direct potable reuse means from the STP it should reach the community. You got it? So option D is correct here. Yes. Which is indirect potable reuse? Which is indirect potable reuse? Can you say the number or the link in the group in the chat? Which is indirect potable reuse. Potable means it should reach the community. It should not from a fresh water because it's reuse. But indirect means from the STP it should reach the river or the groundwater and it will be taken to the city. Here also they are treating effluent, they are putting into the river, but it is taken to the water treatment plant and then to the city. Then here it is effluent is discharged into the groundwater and then it is taken to the potable. So indirect potable is 5 alone. It's not 5 and 4 6 all are correct. 5 and 6 to the community it's 5 and 6. 5 and 6. If there is a direct linkage, that is direct potable linkage. You got it? 5 and 6 are indirect potable reuse. Because the effluent only we are drinking, but after treatment with the groundwater aquifer or from the river. Okay. Some numericals we will try. Read the question. Water is being supplied at 160 liter per capita per day. 160 liter per capita per day. This is a given question. Water supply to the population of 12.5 lakh. Lakh is 100,000 lakh, 10 power 6. 10 power 6 liter, lakh population, sorry, population. So if you capita, if you cancel, capita will cancel. So we are supplying this much liter per day, okay, to the city. City is having 12.5 lakh population, so capita cancelled. Nearly 80% of the water consumed are produced as wastewater. Out of this water supply, 80%, so 0.8 is considered as a wastewater, and 10% is lost. So 10% of this is lost. Total 10% is lost, but 0.9% of this is coming as a treated wastewater, collected and treated. Based on the information, the total amount of wastewater generated. How much wastewater generated? Supplied into 0.8. Multiply 160 liter into 12.5 into 10 power 6 liter per day into 0.8. So this much quantity of liters. So they are saying million liter. So divide the 10 power 6 or divide it again by 10 power 6. Not 10 power 6, 10 power 5, I guess. Lakhs is on 10, 100,000, 10,000 lakh. So 10 power 5, sorry, not 6. 10 power 5, million is 10 power 6. So divide it by 10 power 6 to get million liters per day. So 160. Are you getting 160? 160 million liter per day. It's not 10 power 5 only for lakh. Again, to convert it into million, because if you convert million to liter, 10 power 6. So I want to convert this into million, I will divide it by 10 power 6. Are you getting 160? I'll again explain. 160 liter per capita per day is supplied for 12.5 lakh population. So if I multiply, I'll get the total quantity supplied, out of which 80% is consumed, and of consumed water is considered coming as a wastewater. So total into 0.8 is my total wastewater generated. Out of this, I have to convert it into million liter per day. So I have to divide it by 10 power 6. I will get 160 million liter per day. Are you getting? Yes. So this question, if you see, 160 is correct. See? Okay. Total water available for potential reuse. So 160 into 12.5 into 10 power 5 liter per day, out of which 80% is wastewater. So wastewater is one, totally we are getting again 160 only, right? So 160 we are getting liter, million liter per day we are getting. So out of this, 10% is lost, so 90% is available for reuse, collected and treated, and we can reuse, right? So 160 into 0.9 is 144 million liter per day is available water for reuse. Are you getting? $144. See, 90% we can get as a 10% lost means 90% we can treat and reuse. After treatment we are getting. Okay. So final question is, if the treated wastewater is reused in irrigation, 6 mm per day. Per day I am treating using 6 mm of water. How much area I can irrigate? Potential area I can. So I am getting, last question answer is 144 million liter I am getting per day. So I am irrigating 6 mm per day. So liter I can convert to meter cube, right? So as I mentioned, 144 million is 10 power 6 liter per day. How can I convert liter to meter cube? How much liter is 1 meter cube? Can you say? Thousand, right? The 1000 liter is 1 meter cube. So divided by 10 power 3000. So I am getting meter cube per day. So now I have the value of meter cube per day. They have given meter per day or millimeter per day. So millimeter is 10 power minus 3 meter per day. So if I divide this with this, I'll get meter square. So area of irrigation I will get. So 144 into 10 power 3 meter cube per day divided by 6 into 10 power minus 3 meter per day. So day cancel, meter cube cancel, meter square I will get. So divide and tell the answer 144 into E3 divided by 6 divided by E minus 3. So this much meter square I will get. I want in hectares. So 10,000 meter square is 1 hectare. So divided by E 100,000, 10,000 E4. 2,400 hectares I can irrigate. Are you getting 2,400? Yes, correct. You got it? Yes, simple. All units you please convert into same unit. Millimeter means convert it into meter. Liter means you convert it into meter cube. Then only I can calculate. You got it? This is a basic conversion. Million means 10 power 6. Lakh means 10 power 5. This and all. If you multiply, you will get. Okay. So hope you got the how the 2,400 hectares came. So okay, another 10 questions we can simply go through. Which of the following is the most favorable option? In the three are, what is the topmost favorable? Which is the least favorable? Which is most favorable? Most favorable, least favorable. First, I will try to reduce. That is most favorable. If water is not, wastewater is not generated, why I have to treat, why I have to think about reuse? So I am not generating. That is a good thing, right? So most favorable is reduce. Then if generated, I have to think on reuse. Then I have to think about recycling, after treatment or reclamation. Okay. So most favorable is answer is reduce. C is correct. If you say in the same in solid waste, I'll say 6R criteria. So not 6R, 6 major pillars of integrated solid waste management. I will say always with the example of a printer. If you have a mail, if you don't want to print the mail, then I am reducing. So it's a good thing. I have to think on reducing the waste generation. So I am not printing, I am not generating a waste, paper waste. So that is a good option. Okay, if I really want the mail, how can I reduce? First is not reduce, first is prevention. Without generation, I am first preventing. It's in solid waste. Second is reducing. How I will reduce is instead of printing on single side, I will print on both sides. So instead of 4 papers, I'll get 2 papers. Or instead of 2 papers, I can print in 1 paper back to back itself. So I am reducing the waste quantity. I am producing the waste anyway, but I am reducing the waste quantity. Okay, if the waste is generated, what can I do with the waste? I can think about prevention, reduce, reuse. The same paper, printed paper, I can use for any other what can we say, a packing material or a buffering material, or the paper I can use for writing something at the edges, or we can use for any cleaning purposes. That is a reuse option on the same condition as a paper I am reusing. Or recycling. Recycling is I am trying to extract the material from that. So I can use the paper in the cardboard making. Like cardboards are made from waste papers, right? So I can mix it with the water. I can make the cardboard. That is called recycling. Energy recovery. When there is no material to recover, I'll try to get after the cardboard gets over. I can burn the cardboard. I will get the energy out of it, right? So after getting material from recycling, after getting energy from recovery, final ash will be there, right? That I have to dispose in a proper scientific landfill. So in solid waste, this 6 are the pillars of management. I should not print if the mail is not printed, that is prevention. If the mail is printed on both sides, that is reducing. This is the main. The paper is used for some other purpose on its own form. Then it is reuse. The form is altered in cardboard making. Then it is recycling. After cardboard's purpose got over, I am taking energy out of it. That is energy recovery, or we can say recovery. Prevention, reuse, recycling, recover, finally dispose. The ash from the burning. You got it? So this is the pillars. Okay, I just wanted to share that. Okay, see this regarding which is incorrect statement they are asking. Recycling reclaimed water treated to secondary standards is suitable for drip irrigation. We need tertiary standard, right? Okay, for the drip irrigation. Wastewater recycling help in reducing pollution by preventing the interaction of sewage with the natural water system. Wastewater recycling help in reducing pollution. Okay, by preventing the interaction of sewage with the natural water system. That is correct, right? We are not putting it in the natural city. We are using, so pollution load is reduced. So statement 1 is incorrect, statement 2 is correct. You got the system?
So can you explain again once?
Yeah. For drip irrigation, as I mentioned, always irrigation, TDS need to be removed. Otherwise, TDS is what? Dissolved solids, total dissolved solids. Otherwise, soil become saline. Salt condition will be higher. So, irrigation or agriculture, we have to think on TDS removal. TDS removal will be in tertiary or advanced treatment, not in secondary. Primary will remove the solids or suspended solids. Secondary will remove the organics, BOD and COD. But tertiary and advanced only will remove the dissolved solids, right? So drip irrigation we have discussed earlier in the some problem. Drip irrigation requires TDS removed water. Okay, so this is wrong. But in the second point, if you see, wastewater recycling helps in reducing pollution. Yes, actually it's reducing the pollution. How? Because instead of effluent to be disposed in the water system, natural water system, we are using in some other purposes. So, whatever the contamination going to the natural water bodies, we are preventing here. So, that is a help in reducing the pollution. So, statement 2 is correct, statement 1 is incorrect. You got it? I will explain here. See, suspended solids will have a problem in clogging. So, drip irrigation requires a tertiary treated. Water treated to secondary standard is not suitable for drip irrigation. It will clog the pipe. Second point is help in reducing the pollution load. That is known. I mean, I can have a slide. I don't have. You got it? Yes. This question: which of the following is not an advantage of decentralized wastewater system? Lesser treatment unit required, lesser cost of sewage transportation. Yeah, lesser cost of sewage transportation is correct. More suitable for wastewater recycling. Yes. Treatment can be applied on different scale. Yeah, large scale, medium scale, small scale. We can adopt for household, apartments, or community. Lesser treatment units required is wrong because each point we need to have a different treatment centralized system. So instead of one, we need 5 or 6. So treatment units are higher number we need. So this is not advantage. A is correct answer. Okay. So see, disadvantage we need a large number of the treatment system, treatment plant. That is the problem with the documentation, and there is a burden, there is an efficiency we can't control. There is a problem. Others are advantages only. Okay. Fill the blank in the wastewater recycling. First, we need to collect the generated wastewater. Then we have to transport the sewage to the treatment plant. After treatment, after treatment, it need to be sent to the designated reuse by again we will have a transporter. But this transport is sewage transport. This transport is reclaimed water transport or effluent transport, treated effluent transport. You got it? Yeah. So the blank is reclaimed wastewater transport. See, collection of wastewater, transport of sewage, Wastewater treatment, this is to the STP. In the STP, it will get treated. Then it need to be transported to the designated reuse. The transport of reclaimed water or treated effluent. Fifth question. The use of reclaimed water to create, enhance, sustain, and augment natural water body is an example of. So, the water, wastewater is transported to the STP. After treatment, the effluent is used to enhance the or augment is addition to the natural water bodies for groundwater or surface water as a recharging facility, groundwater recharge, aquifer recharge, or augmenting the surface water, then it is called environmental reuse, industrial reuse, direct potable reuse, none of the above. It's not industrial reuse, it's not direct potable also, because we are sending to the natural system. So environmental reuse, we have discussed, right, different reuse option. Environmental reuse is correct. See, environmental sector, artificial groundwater recharge or augmenting the stream flow. We are adding to the flow, already existing flow, the treated effluent. That is the environmental sector. You got it? Yes. So sixth question, there is a assertion and a reason. In the assertion, treating and recycling grey water is easier than sewage treatment and recycling. Is it correct? What is grey water? Water coming from dishwasher, wash basins, or washing machines. That is easier to treat and recycle compared to the sewage treatment. Sewage will contain grey water plus black water. So first statement, I think it's correct. Grey water contains lesser pathogen, ammonia, and organic load than sewage. It has lesser pathogens, lesser ammonia, and lesser organic load compared to sewage. Is it correct? Yes, correct. That's why it's easy to recycle. So both A and R are true. R is the correct explanation of A. Correct? Yes. Because see, grey water is easy to recycle because it contains less pathogen, less ammonia, nitrogen. It's coming from washing machine, dishwasher, and bathing, or like lesser load. Bathrooms, not from the toilets. Okay. Which of the following resources cannot be recovered from wastewater? Water can be recovered, mineral can be recovered, energy can be recovered, food cannot be recovered. So answer is C. Okay. Eighth question. A safe option to reuse municipal wastewater subjected to limited treatment. Limited treatment. So maybe primary or only secondary. What we can do? Irrigation to non-food crops. Irrigation of landscape and recreational area. Non-contact domestic use. I think all are correct. All seems correct. Non-food crops we can do because no tertiary. Okay, we can do for non-food crop. Irrigation of landscape. Non-contact domestic use. But they are saying a safe option to reuse municipal wastewater. Okay, the source is municipal, but after treatment, where can we do? Limited treated. Can we go for irrigation or not? Non-contact domestic use. Maybe toilets. That is correct. A and B are correct or not? Irrigation, can we go? Yes, all the above. You got it? Irrigation, we can go for non-food crops, landscapes, and recreational areas. But drip irrigation, we can't go with the drip, with the secondary treated. We need a tertiary treatment. Clogging may be the problem. See, after treatment, we can go for anything. Non-contact domestic irrigation for landscape, agriculture, and aquaculture. Okay. The concept of zero liquid discharge entails, again, you all know, it's only for industrial process to upgrade so that water use is drastically reduced. Oh, sorry. All are based on industries. Effluent produced within the industry be treated and recycled for industrial usage. That is also correct. Complete and tertiary treatment of industrial wastewater for direct potable reuse. No, it should not come out of the industry. Not potable. Not potable for the community. Industrial process to be upgraded so that water use is drastically reduced. No, it's not based on water usage. It's based on treatment. Treated effluent be used for steam flow augmentation. No, it's not reused anywhere. Zero liquid discharges, it will not come out of the no effluent. no discharge. So effluent produced within the industry be treated and recycled for industrial use. It will not come out as a reuse. Okay. Yes. No river, no potable, no community discharge, nothing. Okay. Nice. So zero liquid discharge policy, industries to treat and fully recycle for effluent for their own purpose. Okay, 10th question. The approximate potential for reclaiming water from a typical municipal wastewater system. We have already discussed it. If I get 100% of water I am using today, fresh water, I will produce around 90% of wastewater. This is water. I am producing wastewater. That is 0.8% I will reduce, or 0.9%. Out of which again 0.8 to 0.9% will come out after treatment. It will go to STP after treatment. Potential reclaiming water they are asking, right? So it will be 80% of 90% is again 80%. So 70 to 90% will be my reclaimed water after treatment. So water I am using, I am treating. So water to wastewater 90% or 80%. After wastewater to treated water again 80%. So if you multiply 0.8 into 0.8 into 100%, how much it will be? 100, first 0.8 will be 80, another 0.8 will be point somewhere 0.9 you can say. So 80 into 0.9, 72. 70 to 90 we can say. See, 80 to 90%, 10% loss in treatment. Finally, we are getting 70 to 80% or 70 to 90% of reclaimed water after treatment. Okay. 11th question. Three statements were given. Which is correct statement? Industrial wastewater can be reused for construction activities with minimal treatment. Maybe within the industry they can do. Okay. But they have to do ZLD. But industrial wastewater can be reused for construction activity with minimal treatment. The least preferred use of recycled sewage is landscaping, irrigation, and fire production. Least preferred, okay. We are having less treatment only, so we can do for landscape irrigation like park and all, and the fire protection we can do. Recycled sewage will require the highest degree of treatment for direct potable use. That is also correct, because if I am directly using for community purpose for drinking or any purpose, I have to do highest degree of treatment. So that is also correct. So all the statements are correct. If the first statement correct, second and third are correct. First is industrial to be used as a construction application. I think all are correct. No. Why? One is correct, two, three are correct. Okay. Two, what is the problem? The least, oh, sorry. Not least preferred. I'm saying it can be used for irrigation and fire production. So the least, the most preferred use of option is irrigation and fire production. If it is less treated, you can think about fire production and irrigation because huge quantity. I think I just inferred wrong. Most preferred. I told it's most preferred. Okay, so 1 and 3 are correct. See, industrial sector wastewater we can use for construction activity. Municipal wastewater we can do for fire production. So that is also correct. But preferred for, they said least preferred. It should be preferred for fire production. Third question is recycled sewage high degree of treatment is required for direct potable reuse. Okay, 12th question. Hope you're clear with that 11th question. If you want a more explanation, you please ask. Okay. Possible risk of using reclaimed water for agriculture and aquaculture purpose could be risk in using reclaimed water in agriculture and aquaculture. Reducing salinity. No, it will increase the salinity. Bioaccumulation of toxic chemicals. Yes, as I mentioned, the fish aquaculture means fish may eat the element and it will accumulate in its body. So bioaccumulation will be the problem risk. Decreased nutrient in the receiving soil. No, it has a high nutrient. So B is correct. You got it? Yes. Coming to the 13th question. Which of the following is an appropriate example of indirect reuse of reclaimed water? Indirect. So first wastewater, collector, STP, treatment, after treatment, going to groundwater recharge or surface water recharge, then it is a indirect. Directly going for waste water treatment plant, that is a direct. So recharge of groundwater is correct. Tile flushing is direct use, irrigation is direct use, domestic gardening is also direct use. Groundwater recharge is the indirect use. You got it? Yes. Indirect potable reuse is wastewater treatment plant. It's directly moving to the groundwater or surface water aquifers reservoirs. Surface water reservoirs, groundwater aquifers. After that, it will be taken to the blending with the water treatment plant. Okay, 14th question. DAS is a relatively safer method of recycling untreated domestic wastewater within the household premises, which is safe to recycle. Bathing for what purpose we can use? Bathing pet, kitchen gardening, floor washing, toilet flushing. Floor washing will come in contact with the human being. Kitchen gardening is and all not good. Bathing pet is also direct contact on the skin. Toilet flushing we can go. That is the easiest option we can do for any reuse as a non-contact. See, domestic application for non-contact application, we can think about toilet flush as a new philosophy. Older philosophy is direct to the agricultural field. Okay, final question. Treated wastewater blended with water in a raw water reservoir of the water treatment facility is an appropriate example of wastewater transport, STP, treatment, moving to the reservoir or a river that is taking water for the water treat, not the water treatment plant, and then it is community will generate the wastewater. One second. Okay, now if you say, they are saying the treated effluent is directed to the reservoir where it is taking to the WTP. What is this called? Direct potable, indirect potable, non-potable, restricted impoundment. I think it's reservoir they are sending. Okay, so indirect, again that is taking to the water treatment plant, so it's a potable. So indirect potable reuse. Yeah, B is correct. Why direct? They are saying raw water reservoir of the water treatment facility. No, it's not direct, it's indirect. Indirect potable. Let me change. Indirect potable. The figure is also wrong. Think about this figure. Indirect potable. See, after treatment, it's going to the surface water supply reservoir. That is supplying water to the WTPs. Right? So that is the, or if you see this one, yes, see here, sorry. It's supplying water to the water treatment plant here also. Directly to the water treatment plant is also direct potable. Let me correct my mistake. Yes, direct is correct because see the backside armor after treatment they are sending to the blending process along with the surface water reservoir to the water treatment plant. They are putting the water, that is also direct. We can't think about direct crop application and all. This also direct, but indirect is only to the groundwater and the surface water reservoirs. But blending with the water treatment plant water, received water, that is a direct potable reuse. You got it? Don't get confused. Be clear with the direct and indirect. Okay? Yes. If you are going for surface water reservoir and groundwater aquifer, then it is a non-potable. Otherwise, it is potable. Yes. If it is not sending to the community, then it is a non-potable. Okay. Okay. Got it. Thank you. Thank you so much for joining today. If you have any doubt, you can unmute and you can ask. Otherwise, you can leave the meet. So we'll meet next Monday, 68 for the last week session. Thank you all. Thanks for joining.
Sir,
Yeah, please.
this is the last week. That's why I'm asking this question, sir. So this subject, how much would we contribute in practical projects? Which field you going to working on this?
You're saying the application part.
Yeah, right. Sir. In practical oriented project.
Yeah, you can. All the STPs are focusing on the wastewater treatment plants. You can go like this will be applied everywhere in the wastewater treatment plants.
In the place of your industrial or
Everywhere. STPs, ETPs, effluent treatment plants from the industries. STPs are municipal wastewater treatment plants. Anywhere you can think about wastewater treatment and recycling part. Again, to the community level, as a city planner, you can think on recycling and reuse part. How to supply the treated, same like water supply from a water treatment plant to the community. Wastewater also how to treat and reuse to the same pipeline. That also a city planner is required to do that. So everywhere wastewater recycling we can apply.
so mostly in agriculture level,
You are asking
which
where to apply. Okay. So the treated water, that's what I have said. Any one guidelines you can follow, US EPA, WHO or Indian CPCB guidelines. Where we can put the water is based on the quality of the wastewater treated effluent or the degree of treatment that we have done. So if the turbidity matches, if the pH matches, if the solids and the organic matter matches, if the pathogens are nil, then we can think about the agricultural for edible crops.
yeah, right. So in the community we are building great apartment, three-story or multi-story apartments, and
Okay,
the domestic water is coming from the apartment.
okay.
We are using the treatment level, desired treatment level, which is better. You are using tertiary treatment level, or that must be based
No,
on target
you
crops.
have a you are constructing or you have a already treatment plant there.
The construction has been done, sir, and now you
No,
suggested
what is
which
the
one.
treatment there? ASP, yeah.
Yeah, right, sir.
So ASP, after ASP, what we can apply for? That's what you were questioning, right? I think we
For,
can go only for nearby gardening. That is not edible, just a garden. Because ASP, I don't think much. Only the organics will be removed, nutrients will be there, and pathogens will be there after settlement also. So we can think about gardening, non-contact applications.
like we are here the recommended tertiary
The
treatment.
tertiary
So
treatment we can do, but based on the land availability. But again, cost will be, that's what I had said, O&M. Operation and maintenance cost will be in on the head of the people living there in the apartment. So nobody will accept because tertiary treatment will be costlier. Why we need to remove all the pathogens, all the solids, all the dissolved solids? Where will we use again? If we get the fresh water, again it is not drinkable. We can go for some what we can say vehicle washing or swimming pool also it's direct contact. We can go for some lawning like recreational facilities only. So no need of tertiary treatment.
So among those three treatments, which one is the better if you are to suggest your secondary or tertiary apprentice?
For the apartment, tertiary is secondary is better. For industry, we can go for tertiary because it's
Oh,
mandatory for them is ZLD. Yes.
thanks for this, sir.
But based on the city where you are living, if you're not getting waste water, then you can think about the water from the wastewater.
Okay, but you have the tertiary is that removing all the
All the
uncontaminated,
yeah, yeah.
all
As I
uncontaminated
mentioned, if you
particles from
go
the
with
water.
membrane technology at the end, you can also make it a like a drinkable level. But are you that much having that much scarcity of water? You can think about this.
Yeah.
But even ASP, if you maintain properly, the effluent quality will be very high. Good quality you can get. But I don't think ASP, if you are maintaining with a skilled person or a proper food need to be there. Food is our waste. Proper food without fluctuation, proper timing. If you operate with a proper aeration condition without any clogging, ASP will result in a high degree of treatment.
In
Even
simple say
secondary.
it was simple in say it was advanced treatment, but that's the reason required skilled people are working to operate that, right, sir?
Sorry, I didn't get you.
It was the advanced treatment, so it was required as skilled peoples
Not
because
advanced,
of
like ASP is simple, but the maintenance should be proper. We have to even like a pump is required for aeration. If I switch off the pump to save the electricity, then what will happen? Nothing will happen in the biological system. So again, the water that is coming out will be same like the influent water. So people are not doing it properly. That's the problem.
okay, so thanks.
So if you have a special operator for your STP in your apartment, that operator need to be, I mean, any private agency who is taking care of all the STPs in the city, like all the apartments they are doing, that vendor agent should be very ethical to maintain that. Then it will be proper. The water outlet water will have a good quality only after ASP, after sedimentation, I think so. But I don't think in a small community have ASP and sedimentation tank. That is good only. If it is a higher level of treatment, you check with what are the treatment options they are having and let me know in the next session if possible.
Yeah, right, sir.
Okay, okay. 12th week we will discuss. Thank you.
Thank you, sir.
Bye bye. Let me close the meet. Thank you all for joining.